Hello everyone, welcome to the channel. So in this video, I'm going to show you how to find a perfect town location using a vector-based suitability analysis in ArcGIS. So now let's get started. So now let me explain about what is a vector-based suitability analysis. A vector-based suitability analysis is a spatial analysis technique used in GIS to determine the suitability of different locations for a specific activity or the purposes. Unlike raster-based analysis, which is use grid cells to represent the data, the vector-based analysis relies on vector data such as point, line, and polygon to represent the spatial features. In vector-based suitability analysis, the process typically involves overlaying a multiple vector dataset representing a various factors or criteria that influence the suitability. These factors could include a land use, soil type, slope, distance to amenities, and other relevant variables depending on the specific applications. The analysis aims to identify the area that meets the predefined criteria or the condition for a particular activity or a land use. By combining and weighting different criteria, the GIS analyst can generate a suitability map that highlights an area with highest suitability for an intended purposes. So vector-based suitability analysis offers several advantages, including an ability to incorporate a complex spatial relationship and the flexibility to work with diverse dataset representing different types of features. It also allows for more precise delineation of boundaries and features compared to the raster-based approaches. Overall, the vector-based suitability analysis is a powerful tool for decision making in various fields such as urban planning, environmental management, and agriculture and natural resource management, and helping stakeholders identify an optimal location for different activities while considering the multiple factors and constraints. So now let me get back to my RGIs. A suitability analysis is generally a common sort of workflow in GIS, and you can think of it as a very general as just finding a best spot for something or finding where something likely to occur. And I could call it as just an analysis that combines the layers that represent the landscape variables and the condition to come up with some sort of a final scoring or the map that shows the best location for something to be built or the something to exist or something might occur. And this is oftentimes done as a raster processing workflow due to the ability to actually have a different scores for the cell based on the location. And but it can also be done as a vector, which is what we will do in this video. So before we get started with it, some type of suitability modeling includes the best place for a new business or some other facility that supports a business, and the optimal path between the multiple locations, or generally a location where some things are more likely to occur, or the best place for the humans and animals to live. And it's sometimes called as an habitat suitability analysis, and the place with the most potential for an access to certain resources, and the place with the mixed that is the best mix of benefits for the users of some sort of whether a national park for preserving a resource or the locations that a species is likely to occur based on the habitat variables. So now we're going to perform a suitability analysis for a best place to locate a town. And it can be hard to say that what is the best place for a town is. And I think it underscores some of the uncertainty and the suitability analysis. A suitability analysis is informed by what variable we think actually matters to the location of something. And if we don't understand what variable influence the choice or that particular phenomena, then we might not get the correct suitability analysis. So for the study, we're going to use many variables that might influence where the town could want to be. And these variables may vary based upon the area we are searching in. So now the variables we chosen for this particular analysis is already clipped. So we can able to visualize it from the table of contents section. We have selected a major rivers and all rivers. Let me show you here. So we have selected all major rivers and we selected all rivers and we have selected roads, and this particular represents the urban setting, and protected areas are represented in green, and the floodplains are represented in blue, and the DEM are represented with the highest level of elevations be indicated in white and red, and the lowest level of elevations be indicated in this color. And now we're gonna try to find the best spot for our town in this location. So based on this data sets, I think we can come up with the best location that could be good for a new town. So now let's do a simpler suitability analysis, and this will be a mix of erasing areas that we can't build, and clipping our analysis to the areas that we want to build. So now let's get started. So the first thing, let's build an area of the extent polygon. So we're gonna do that using our digital elevation model, which represents our area of least data. So it's our search area because all of our other data extends further. So this is only data which represents a least area of least area compared to other data which extends further. So other data extends further than it, and this extends our DEM extends the least. So now to create an extend polygon, we're going to navigate to our tool called the Arc toolbox. We're going to click this. So for that, we're going to navigate to this tool called Spatial Analysis tool. In that, we're going to navigate to this tool called raster creation. And we're going to click the first tool called create a constant raster. We're going to click this. So now the tool has popped up, that is create constant raster. So now choose your output file location. So now here I'm going to enter the name as a constant raster. So now I have entered as constant raster. So now click save. So now let me add .tif. So now choose a constant value. We're going to enter as 1. And here the output data type will be integer, and the output cell size, so the output cell size is we're going to enter as 10. So that is which matches the resolution of our DEM data, which is 10 meters. So we're gonna enter as output cell size will be 10 meters, and we're gonna set our output extent. So we're gonna set the output extent to match our same as our DEM layer. So now we're gonna navigate to this option called environments. Here we're gonna navigate to this option called processing extent. In that, we're gonna set our extent as same as layer DEM, and we're gonna navigate down here. We're gonna click raster analysis, and in that we're gonna click our mask to be our DEM. So once you did that, we're gonna click OK, and also we're gonna set up our coordinate system. So for that, we're gonna click environment again. So we're gonna navigate to our output coordinates. We're gonna set the output coordinate system to be same as the layer DEM. And once you did that, we're gonna check for processing extent, and we're gonna set to the default value the extent, and the snap raster to be our DEM. So once you did that, selecting coordinate system, processing extent, and the raster analysis, so we're gonna click OK. And now click OK to run this tool. So now you can able to visualize create constant raster. A constant raster has been created here. So here I got this black raster covering up my existing raster. Let me drag to the top here. You can visualize it. So this is the constant raster. So now here I'm gonna navigate to this constant raster, and that you can right click and click this option called properties, and in that we're gonna click this option called unique values. So you can change the color of this particular black, or you can change to any color. So you can select property for selected color, gonna select red color and click OK. So now we're gonna drag to below floodplain here to visualize the other layers. And now I want to do a search for a raster to polygon. So for that, we're gonna navigate to this option here. Let me drag this, and let me enter as a raster to polygon. So here I have entered as raster to polygon, and we're gonna click search So once you did that, we're going to get the first result here, that is raster to polygon. That is our conversion tool. And hence, these all have exactly the same value amount in this raster. It will convert. It will convert to a single polygon that I can then use as a basis for my suitability analysis. So now we're going to click this tool called raster to polygon. So here we're going to insert our input raster will be our constant raster, and we're going to leave the field as a default value, and the output polygon we're going to enter. Let me select my output location for this particular conversion. So now I have entered as the extend polygon. I'm going to click this option called save, and we're going to remove the tick mark here. So we want it to be just be exactly the way it's converted. So now we're going to click OK. So now we have our result. Raster to polygon has been converted. So here we can able to visualize this is the extend polygon, and which should have just one feature in it. So we can right click and click this option called open attribute. So yes, it has only one feature. So let me close this. So now let me remove this constant raster here. We're gonna remove this. So now let me place this extend polygon below my floodplain data, so to visualize all of the datas. And basically what we want to do with that initially is to remove the areas that we know we don't want to build. So number one is we don't want to build in the floodplain here. So you can able to see that this is a floodplain, and we can't build where the existing towns are, or so basically we can't build any new towns in the existing towns. So these are the urban areas. You can able to visualize the orange color here represents our the existing urban areas. So we can erase those, and we can also can't build in protected areas. So here the protected areas been represented in green color. So you can able to visualize in the screen, these three are represented as a protected areas. So we can't build any towns here. So based on this, let's erase the three of those from this polygon. That is our floodplain and existing urban settings and the protected areas. So we're gonna basically use this three polygons, that is our urban setting, floodplain and protected areas. So we're gonna erase this polygons from this polygon. So we're going to use these three polygons to erase from this base polygon, that is in our extend polygon, so that we can see what areas we have left to build in. So for that we're gonna need a erase tool. So we're gonna navigate to the search section here, and let me enter as the erase tool. So here you can able to visualize I have entered as erase. We're gonna click search, and we're gonna click the first result called erase analysis tool. So the tool has popped up. So in the input features, we're gonna insert our extend polygon. So let me select my extend polygon here. So the extend polygon is this particular polygon we have generated here. So this particular polygon, and the erase feature we're gonna include, and the erase feature we're gonna select will be our urban setting. So let me select that, and let me select my output file location. So I'm going to enter as the suitability analysis step 1. So now I have entered as the suitability analysis step 1, and we're going to save. And now we're going to click OK. So where erase tool has run, so we can able to visualize our suitability analysis step 1. So this is our suitability analysis step 1 here. So let me turn off the urban setting here. So you can able to observe a hole in our polygon here. So let me turn off this extend polygon here, and the dim. So you can able to observe there is a hole in our polygon, that is suitability analysis step 1. So now let me turn on the dim here. So now some of the protected areas, is also in that area. Let me show you that. Let me drag this below the floodplain here. So able to view that we have our protected areas also. So now let's go to the erase tool and erase the rest of the protected areas from our existing suitability analysis step 1. So we're going to click the erase tool again, and the input feature will be our suitability analysis step 1, and the erase feature will be our protected areas. So now let me select the folder location to save this. So we're going to enter suitability analysis step 2. So now I have entered as suitability analysis step 2 and click save. So now we're going to click OK. So we are just stepping through each of this removal of this area that we can't build, and the remaining areas in the polygons are the areas that are still potentially suitable. So now we have our result here, that is suitability analysis step 2. So let me turn off my step 1, and let me turn off the protected areas. So you can able to visualize, first we have removed our urban setting, and next we have removed the protected areas in our polygon. So here the remaining areas in the polygons are still potentially buildable until we finish our analysis. So now the third one we want to erase is to erase the floodplain areas. So for that we're going to navigate over erase tool again. So in that input feature will be our suitability analysis step 2, and the erase feature will be our the floodplain. We're going to select floodplain, and let me choose my output file location for this particular file. So let me enter as suitability analysis step 3, and now click save, and now we're going to click OK. So now we have our result, that is our suitability analysis step 3. So we're going to turn off this and the floodplain here. So now we can visualize it. So now we can able to visualize it. Let me turn off the dim here. So we have the gap here. So we don't really want to build in the floodplain because they have disaster prone areas. So now let me turn on the dim here. So now we have actually removed a lot of potential areas in our research window here from the consideration already, and these are the hard and past things. So these are the things that we definitely can't have. That is potentially we can't build in those areas. There is an urban setting, floodplain, and the protected areas. And also we can consider another important parameter. So we can generate a slope raster from the DEM, and we can say that we don't really want to build on areas with the high slope. So that could be another thing we can erase to find more suitable areas for our town location. So now what about the positive things, like the things we want to make sure we have? So maybe we want to make sure that we have a good connectivity to the major roads. So maybe we want to have at least a part of the town to be within and about a kilometer of the road. So let's buffer the roads by a kilometer, and then we can intersect that with our existing horizon here. That is, we can intersect with our existing polygon here. That is our suitability analysis step 3. This is our existing polygon. And then we get the areas that are only within a kilometer of existing roads. What is our fourth requirement is to maybe we want to have at least a part of the town to be within and about a kilometer of a road, of the road. So for that we're gonna buffer the road by a kilometer, and after that we can intersect that with our existing polygon. That is our suitability analysis step 3. And then we're gonna get the areas that are only within a kilometer of an existing roads. So now let's find our buffer tool. We're gonna navigate to our Arc Toolbox section here. So for that we're gonna navigate to this tool called Analysis Tool. In that we're gonna click this tool called Proximity. So in that we're gonna click this tool called Buffer. So now we have our buffer tool here. So now the input feature will be our roads layer. So we're gonna click this, select this roads layer. So the linear units, we're gonna click the kilometers, and we're gonna click 1. So that is 1 kilometer. And now let me choose my output file location. So we're gonna enter as road buffer 1 kilometer. So now I have entered as road buffer 1 kilometer, and we're gonna click save. And I'm gonna leave the rest of the things to be default. So we're gonna click OK. And now we have this layer that represents the everywhere within a kilometer of roads. So we have this layer here, that is road buffer 1 kilometer. And all the pink we can see is what's going to get excluded when I run an intersect tool of this buffered layer. against this existing suitability step where we remove the things we can't have. So if we intersect them, we get only the areas where they overlap. So we won't get the rest of this rest of the stuff that we don't want down here in the floodplain. We will get only the part where it overlaps. So now we're gonna navigate to the Arc toolbox. In that, we're gonna navigate to this particular tool called Overlay. In that, we're gonna click this tool called Intersect. So this is the Intersect tool. So now in the input features, we're gonna intersect our roads buffer 1 kilometer with our analysis suitability analysis step 3. So now we're gonna select my output file location here. So we're gonna enter as suitability analysis step 4. So now I have entered as suitability analysis step 4 and we're gonna click save. So once you did that, we're gonna leave the rest of the things as default and we're gonna click OK. And now our intersect tool has run. So we have our result, that is our suitability analysis step 4. So I'm gonna turn off this road buffer 1 kilometer and suitability analysis step 3. And also we're gonna turn off my dim layer here. So here I'm left with this thing here, that is our, so you can see that I am left with this polygon here, that is our suitability analysis step 4. And now I don't have that much areas left for my new town location. So all the pink areas here represents our possible new town locations. And now just a kind of final step. Let's say also that we think that aesthetically the members of the town could like to be near some sort of a river here. So let's also find a location that are pretty close to the some rivers. So once again I'm going to buffer and intersect. So now we're gonna navigate to this option here to Arc toolbox. In that we're gonna click the proximity tool. We're gonna click the buffer tool here. So in the buffer, the input feature will be our major rivers. And let me choose my output file location. So I'm gonna enter that as a river buffer 1 kilometer. So now I have entered as river buffer 1 kilometer and we're gonna click save. And the linear units we're gonna select is gonna be kilometer. Let me enter as kilometer and I'm gonna mention as 1. And now I'll leave the rest to a default and now click OK. So now our tool has run here. We have our river buffer of 1 kilometer. So now we're going to navigate to our intersect tool. We're going to intersect our river buffer of 1 kilometer and our suitability analysis step 4. So for that, we're going to navigate to our Arc toolbox here. So in that, we're going to click our overlay. In the overlay, we're going to select this tool called Intersect tool. So now this is our Intersect tool. So now the input feature will be, we're going to select the major, that is our river buffer of 1 kilometers. And then we're going to intersect with it with the suitability analysis step 4. And we're going to save to a folder location. So we're going to save it as suitability analysis step 5. And now we're going to click save. So now we're going to click OK. So one of the great things about us doing this in vector is that it is very fast in a lot of these cases. So now we have our suitability analysis step 5 here. So let me turn off the river buffer of 1 kilometer and suitability of step 4. And now here you can able to visualize we have left with only a few areas where we can which will be perfect for our new town locations. And now let me turn on the dim data here. And let me change the color for this particular area. So let me make some let me add a good dark green to this color here and click OK. And now we can able to easily identify it. So basically we are left with only few locations, and maybe what I could want to do is maybe dissolve this boundary and I can see them a little better and actually start evaluating based on some sort of an objective criteria now. Maybe this area in here has a large contiguous areas of land might be a perfect spot for new town locations. And certainly we could continue on with our analysis and add more and more variables until we really narrow it in. So basically this spot could be a most suitable area we can where we can able to have a good town location, a perfect town. So it has a large area, and also we have our and also as well as the members suggested from our town stated the requirement of their town to be closer to a river. So as suggested, this particular area has a large area, and also it has a river closer to it, and this could be a best town location. So this could be our best town location here for our new town location. So in this video I have shown you identifying a perfect town location using a vector-based suitability analysis in ArcGIS. So thanks for watching, and please subscribe to our channel and give us a like.